All right, we're in lesson 3.4, writing proofs. We're going to actually start writing the proofs today. These are algebra proofs. We'll transition into the geometry ones later on, but this is just kind of an intro to how to write proofs, the two-column format, and things like that. So if you open up to 3.4, there's a bunch of properties in there that we're going to use in the proofs. So these are properties that you've been using forever. What I did is I just wrote them in my notes, took a picture of them. If you need to pause the video to get those written down, you can. I am going to just kind of talk through them here. So if you need more time, feel free to pause to make sure you can get them written down. 4 properties here. You're adding, subtracting, multiplying, and dividing. The property of equality just means whatever you do to the left side, you can also do to the right side. You have to do it to the right side to keep the equation balanced. So this first part right here, if a equals b, then a plus c equals b plus c. That's just saying that whatever you add to the left side, you got to add to the right side. Okay, same with subtraction, multiplication, division. It's the same thing. If you subtract something from the left side, you also need to subtract it from the right side to keep it balanced. And again, this is something you've been doing for years. We're just going to call those subtraction property of equality. They're all properties of equality because we do it to both sides of the equation when we're solving for x. So pause if you need to get that written down. And again, your notes are yours. So if you don't need to write all this down, if you understand what those property of equality mean, just means you need to do to the left side what you do to the right side, then just keep moving through. Okay, the next one's here, distributive. Again, you've used it forever. It's when you distribute into parentheses, right? That's called the distributive property. Substitution, it says if a equals b, then you can put a in wherever b is anywhere in the equation. You're substituting it in. Notice these are not properties of equality because you don't have to distribute to both sides of the equation. That's just when you're adding or subtracting, multiplying, or dividing. This is usually happening on one side of the equation. The reflexive property doesn't come up yet. It will more in geometry, but it just means a equals a, which is kind of silly. Kind of skip that for now. We're going to use that later on in the geometry proofs. Symmetric we use a lot. It's just saying you can flip-flop the equation. So if in the end of the problem you have 2 equals x, if you use the symmetric property, you can flip-flop it to where x is on the left side. So x equals 2. Those mean the same thing. Transitive, if a equals b and b equals c, then you can kind of cancel out the b's because they're equal to each other, then a equals c. Okay, so again, pause if you need to get that written down. We'll keep moving through here. Okay, now into the notes here. So a 2-column proof. This is how we're going to organize all of our proofs. On the left side of the proof is what is called the statements. Okay, the statements for these algebra problems is where we're going to actually do the algebra, where we're going to solve for x. On the right side is where our reasons or our justifications are. This is where we're going to say like addition property of equality, distributive property, or transitive, or whatever we're going to be using. What can be used for the reasons? Really just all the defined properties in geometry, okay, or even in algebra. Defined properties, meaning like, for example, the ones we've already done, like addition, subtraction. These cannot be made up reasons. These have to be concrete, proven postulates or properties that we don't have to prove to be true. They're already proven to be true. And we're going to give you a list of those as we keep going through these proofs. All right, moving into the proof, this is what it's going to look like. Okay, these first few are really guided for you. The left side is worked out. We just have to give the right side the reasons. Okay, the first step in every proof is we're going to rewrite. They're always going to give us a given. Maybe they give us a few givens. When we get to the geometry proofs, there's going to be quite a few givens. You need to rewrite all of those out in your proofs. You can't skip steps in proofs. That's key. Okay, so the first line is you're just rewriting that, and you're going to write given. It was given to us. Okay, now we need to look how we got from step 1 to step 2 is we got rid of the 1, right? And in algebra, we add 1 to both sides, and we get 28. Okay, so that is the addition, and if you want to abbreviate here, addition POE, property of equality. We added 1 to both sides, so that's addition property of equality. To get from 2 to 3, the 4 disappeared, right? And we know that the 4 disappeared because we divided it on both sides. So when we divide it, that's division property of equality. We divide it on both sides. Okay, the work I show on the left, you don't need to show in the proofs. I'm just kind of showing you just so you see what's going on. But this stuff over here, you don't need to show any work over there as long as you have your reasons down. Okay, example 2. Again, we rewrote the given. Okay, the left side's filled out for you. Right side is given. Now we just see how we got from 1 to 2. Okay, it looks like the 2 disappeared. How did it disappear? We subtracted it from both sides. So that's subtraction POE. And then from 2 to 3, the -6 disappeared. It's being divided, right? It's in the denominator. We multiplied the -6 on both sides, which gave us -18. So that is multiplication POE. Okay, and if you notice here, this matches our proof part. So we wrote our proof for that algebra problem. Next one, example 3. Okay, the given is there for us. So we can see that the parentheses disappeared, so they must have distributed the -9 in there. So that's the distributive property, not POE. Okay, this is where that comes into play. We didn't distribute on both sides. It's not property of equality. We just did on the left side, so it's just distributive property. From there, let's see, the 27 disappeared, so we must have subtracted that from the 63, so that's subtraction. And we did it on both sides, so POE. Okay, I also noticed there's a typo here. This should be an 18. That shouldn't have changed to a 28. And then to get x alone, we divide the -18 out and get -2, so that's division, property of equality. All right, couple left here. Now we got to do a little more work. The left side is not done for us, so we actually need to show the algebra on the left side. Okay, and how you solve these is kind of up to you. There's multiple ways to get x alone. You could move the x to the right, to the left. It really doesn't matter as long as you justify your steps. Okay, now in the proof, notice that the x is on the left. So we're probably going to want to move everything to the left, just so we don't have to use that symmetric property at the end. It's not wrong if you have to switch it at the end, but it would just add another step. Okay, so what I would probably do first here is I would subtract 8x on both sides. And if I did that, I would get -2x plus 7 equals -17. Don't lose your negative there. Okay, and I did that by subtracting the 8, right? So that is subtraction POE. I subtracted on both sides. Next, I'm going to subtract 7 over to the right. So I'm going to have -2x left equals -24, which again I subtracted, so that's subtraction POE again. And then my last step, I just need to divide the -2 out, which gives us 12. So I divided, so that's division POE. Now I have a step left. That would be just if you needed more steps. You don't always have to fill out all the steps that are given to you or listed for you. As long as your answer matches the proof, then that proof's done. All right, last one. So what we have here is we need to solve this big long problem. So again, lots of ways to do it. What I see right away, I see parentheses, so I'm going to distribute right away. Okay, and if you're doing distributive property, I don't mind if you do that on the same line, if you're doing the same reason. So let's just combine that. Let's go -7x minus 14 plus 4x equals 12x minus 24. And I did distributive property, not POE. Right? I know I did it on both sides, but it's really the distributive property twice. Okay, now we have options here. Okay, what I see on the left side, I see those two x's, so I'm going to combine those. -7x and 4x is -3x minus 14 equals 12x minus 24. And we haven't talked about a step for that, but that's really just combining like terms. Okay, again, that's not in our notes earlier, but that's just a common step that we've done before. I see the x on the left side in my proof, so I'm going to move the 12x to the left. So I'm going to get -15x over here minus 14 equals -24. And I move that by subtracting it, so that's subtraction, POE. Okay, then I'm going to add my 14 over, so I'm going to be left with negative 15x equals negative 10. And I did addition POE. And my last step, I just need to divide, and this doesn't look nice, right? 10 divided by 15 is not a nice number, but that's okay. If I get x equals 10 divided by 15, the negatives cancel. Okay, if I'm left with 10 over 15, just look up at the proof. We got to get to 2/3. Okay, so when I do that, let's call that division POE, right? I divided. To get to the 2/3, if I add one more step in here, we know 10 over 15 is 2/3. Okay, if over here, if you want to write like I reduced the fraction, okay, or simplified, okay, that would be fine. We know what you're saying there. Okay, so that's what the algebra proofs look like. We're going to stop there for the notes today. We'll get more into it, and we'll talk more in class as I get back to school here. But in your homework packet, there's a worksheet that's called Algebra Proofs. Go ahead and pull that out and work the rest of the time. Thank you.